Okay, so I think let's go ahead and get started. There might be some people still joining us, but they'll be able to catch up. So welcome to the 2020 MSU Turf Grass Golf Turf Virtual Field Day. We would love to be in person on site. It is a beautiful morning. For those of you that have attended our field days in the past, sometimes you've noticed we've been dodging rain clouds. That is not the case today. But due to COVID restrictions many of us are under, we're unable to have the typical field day we would normally experience during August. So just some introductory comments, of course, maybe not, of course. My name is Kevin Frank. I'm one of the professors, and I'm a turf extension specialist here at Michigan State, and I'll be kind of guiding you through this next hour of presentations. The format, we will have pre-recorded videos from our speakers, and then once those videos conclude, we will then have an opportunity to ask questions to the speakers. If you do have questions at any time during the presentations, feel free to put those in the Q&A box at the bottom of your screen. If you click on that question and answer box, you can type in questions there. There also is a chat function on Zoom. If you do end up putting a question there, we'll do our best to try to monitor it and see that also. But if you can, use the Q&A box. That makes it a little cleaner for us. This program is approved for credits. It has one pesticide recertification credit in either commercial core, private core 3A, 3B, or 6, and it also has 0.1 education points from GCSAA. Now, I think to start off this morning, one thing we should do is acknowledge that for all the golf course superintendents that might be attending, this is Thank a Golf Course Superintendent Day. So let me be the first to, if you haven't been already thanked, thanks for all that you do in providing excellent turf grass conditions for all the golfers out there and sustaining environmental quality. So thank you for all your efforts, and I'm glad you could join us today. So with that, I think we will go ahead and begin with our first video, which is Dr. Joe Vargas and Nancy Dykema talking about turfgrass pathology here at the Hancock Turfgrass Research Center.
Hi everybody, this is Joe Vargas at Michigan State University in Department of Plant, Soil, and Microbial Sciences. We've been doing crown rot anthracnose studies for many, many years, and over the years we had many products that worked. But over time this fungus has become resistant to most of the newer chemistry that we have. And you could see throughout here that we have a lot of areas that are really brown in color, and that's because the fungus, the crown rot anthracnose fungus, has been killing the annual bluegrass turf. Out here we have resistance to the QOI chemistry, we have resistance to the DMI chemistry, and we also have resistance to thiophanate methyl. And if we go throughout this study, the thing that we find that still works are the old-fashioned fungicides, the contact type fungicide. Premium and Ultras, both of which contain PCNB, are working very effective out here. Any program that has Daconil in it, including the standby Daconil signature program that many of you use, is also working. And then the Florentine program is also working, and it, in addition to all the fertility and biostimulants that are in there, it also has the chlorothalonil product. So again, I think many of you are seeing that out in the field, and it's not so you know what you're seeing. It's resistance, and you need to go to contact type fungicides in order to bring it under control.
Hi, I'm Nancy Dykema. I'm a research assistant at Michigan State University with Joe Vargas, and we do our disease trials here. And so today I'm going to talk a little bit about summer decline on annual bluegrass. And this is a problem where as the summer conditions become stressful during the heat of the summer, it might undergo drought conditions, the turf goes under stress. We have several treatments that we've been looking at over many years to combat this problem. So it's nice that with these Florentine programs, they're actually starting to look at some other products and put in some experimentals. So we have 3 different Florentine programs that we're looking at this year. They're doing a great job reducing stress. And you can tell because there's a increase in color, quality, density in the turf. We also have both signature with Chipco 26 GT and also Dacano with Signature. And those two products we've tested for many years and are very reliable. And so again, you can see the impact that using these programs and these products have on reducing summer stress on this turf. So this summer in Michigan has been very warm. We've had a lot of temperatures in the 90-degree range. We've had warm nights, and that has been very conducive to many diseases, including brown patch. So we have conducted a brown patch study. We did a curative study, which has looked really good, and this is a preventive study that we did on creeping bentgrass. This particular study included a lot of experimental numbered compounds that looked pretty good. We had a significant amount of disease in our untreated control plot. We also looked at several combination products. We looked at Zio, which is a Pseudomonas product, Soteria, which is fluazanam, Heritage, which is azoxystrobin, and many of these in combination. Compass and Heritage we used as standards, and they both did very well. So the disease pressure out here in the field wasn't quite as much as we have in a hothouse, which I'm going to show you in a couple minutes. So this is a brown patch study that we're conducting. The grass is grown on modules outdoors, and then beginning of the season we bring them inside to this portable greenhouse. The nice thing about this greenhouse is we have misting irrigation, and so that allows us to keep temperature and humidity very high, so the disease pressure becomes tremendous in this area without even inoculating. So our brown patch, of course, developed very readily and quickly in this hothouse, and you can see it going down the alleys of our plots. These are the same treatments that were used out in the field that I showed you. Here with the higher pressure, you can definitely see some differences among the treatments. We have standard treatments like Compass and Heritage that worked very, very well, especially under these extreme conditions. Our untreated control had severe disease, more than 90% disease in the untreated controls. And then we had several experimental products, combination products. Some of the combination products using both Zio and Soteria, which is fluazanam, Zio, which is a Pseudomonas, combinations also with Heritage or azoxystrobin. So under these conditions, when we have the more stressful conditions, of course, some of these products don't hold, even though they're going down every 14 days. So, and you can see those differences in this particular study.
Yeah. Nice to see you.
Good, yeah. I'd just like to add something. At that time, you know, it was probably my brain wasn't working as good as it should have. But there are two other chemicals that are not contact fungicides that work well on anthracnose. One of them being Ballista and the other being Nextine. I'd like to add that. I'm ready for questions.
Well, Joe, I got one for you.
All right.
And I'm sure this won't be a hard one.
There you go.
So it's like this summer. I mean, what did you think about this summer? What did you see or hear from superintendents? Is there any particular diseases they struggled with, or kind of how difficult was it out there?
It was very difficult, and the first comment I'd like to make was if this was 20 years ago, I would have been in my vehicle from morning to night, 7 days a week, running down problems. But I think we've done such a good job of educating the superintendents that even in a hot summer now, they tend to get through. Did we see some odd things? Yeah, we saw Pythium root dysfunction on a golf course that I was surprised to see. And another golf course had a problem with summer patch where apparently fungicide wasn't working. But other than that, I mean, everybody got through this thing great. So, I'm not bragging here, but for all of us, I think we've done a great job in educating the superintendents to where, once in a while they need us, but not like 1995 when I got in my car and drove all day, every day. I did take some off, but yeah, we've come a long way.
Well, that's great to hear, Joe. So, I'm kind of thinking, I was looking at my plots yesterday, a couple studies I have out here. What diseases are you seeing right now? Or what do you expect in the next couple of weeks that people should maybe keep an eye out for?
Okay, one of them is we finally getting some dollar spot out there. Not a very good year from the pathologist's point of view for dollar spot. Unless I think too long, we hardly got any in our plots. And we're getting into those temperatures this coming week where we're going to be ideally, especially if we get a little bit of rain for mycotoxin impacts. We don't tend to forget about it. We think, well, snow mold, we'll get to that in November, but But that micronutrient patch will start in the cold weather way before you make the final snow mold.
One thing I was seeing out there in one of my studies, and this is where I always have to ask you because I'm not a pathologist, right? So is it cool season brown patch? Is it yellow patch? I mean, very, very faint. Like, you know, if you look away from it, you can see it more when you look at it. Just those yellowish, very faint yellow rings out there.
Yeah, it could be yellow patch, or it could also be, help me, Nancy,
Wadia patch,
wadia patch. We found
brown
some,
ring patch.
yeah, we found some wadia patch on the plots. In our plots. That was actually wadia patch, but it might be wadia patch, which is a little more difficult. Quite good.
They're both rhizoctonia kind of diseases, and it's really hard to tell the difference between the two of them when you see them in the field. The temperature range is a little bit different for each of them, and that's often how we can kind of discern without doing isolations.
It's just interesting to me because it is literally like camo disease. I mean, it's literally, I go out there and I look and I was like, I don't even see anything. And then I look a different way and I was like, oh, there's a little something there. But I mean, you know, to me, it's kind of like if that was on my golf course, I'm not sure I would pay that much attention to it right now. But of course, if it gets worse, then it would grab my attention, I think.
And what Nancy said, probably wadia patch because it came when the temperatures were a little warm.
Okay, so I do have a question in the Q&A for you. Just kind of like generally, what happened to dollar spot this year? Was it too hot? It just didn't seem like there was much around until maybe just recently.
Yeah, Nancy and I, and Nancy can speak for herself, but we thought that the temperatures were just simply too high for the dollar spot. You know, like I said, we're beginning to see a little dollars. Nancy?
Yeah, and I think the nighttime temperatures, we had a lot of nights that were in the upper 60s and 70s, and that tends to be a little bit warm for the dollar spot pathogen. It tends to do well where you have, you know, warm days, but cooler nights. Think about those conditions where you get dew formation on the turf. Those are kind of ideal. And not only the temperatures, but also the humidity. So we didn't have a lot of really hot, muggy days where you just, you know, would sweat when you walked out the door. And the dollar spot pathogen also does well when you have a pretty decent level of humidity. So between the daytime temperatures being high, the nighttime temperatures being really high, and then not a whole ton of humidity, we kind of think like maybe it was just too darn hot for it to do infection, you know, to get there and do its job. So yeah, so we think that the weather really had a lot to do with the dollar spot infections. Now that we're getting some cooler nights, now we're seeing it pick up. And so that's, you know, that's kind of why we think we didn't see a whole lot this year.
Okay, excellent. Anything else, Joe or Nancy, you'd like to add before we move to the next presenter?
No, I'm satisfied. I think we covered.
We did have a lot of brown patch this year based on those warm, like I said, the warm nights that we had, which we don't typically have here in Michigan. And our study, especially the one in the hothouse, was really, really good. We had great pressure and had some really nice differences among treatments for that disease if you do have that problem.
One question before you go. Red thread again. Question on red thread. Is there any kind of treatment you can do early in the season to prevent having such a problem with red thread?
Try to keep the fertility level high or adequate at least. And or you can make an early fungicide application. Anyone with DMI fungicide that would also get the initial inoculation.
So Joe, if you're making an early season DMI like in Michigan, when is early? Could you give us a?
I think for red thread early would be sometime in June.
Okay, sometime in June. Okay. Okay. Excellent. Thank you. And now we will move to our second presentation of this morning, which is Dr. Jim Crum and Dr. Thomas Green, which are going to talk about. They're going to talk about some variable depth root zone construction on golf greens.
Hello, this is Dr. Jim Crum. I'm in the Plant Soil Microbial Sciences Department at Michigan State University. I do teaching and research in the area of turfgrass soils and soils management. And what I'd like to share with you today is some research that we implemented in the late 1990s. It had to do with variable depth root zones on putting greens, and not only that, but also introducing a sloping surface. So on these plots, instead of being level and flat, they're sloping with a 10% slope on one side and a 5% slope on the other side to mimic more what happens within the field. We instituted and used 3 different root zone mixes, one with 100% sand, one with a sand, that same sand plus soil mixture, and then that same sand with a peat mixture. We replicated those 3 treatments twice, with once the second treatment or second variable was the depth at which the root zone was within the putting green itself. In one, we had a consistent depth where it was from the top of the slope to the bottom of the slope. It was a consistent 12 inches of depth. On the other, it was a variable depth where it was about 8 inches deep, the root zone itself on the upper summit parts of the slope, and then to 16 inches deep in the lowest landscape positions. We did that to increase the amount of drainage that will occur in the lowest part of that putting green. Now these are a little over 20 years old. They have been managed, and our interest in today, and we've also submitted to the United States Golf Association a research proposal to look at these 2 different kinds of construction techniques, whether it's consistent depth or variable depth, to try to look and see how those putting greens have matured. Hopefully we're going to be successful. Those involved are Dr. Kevin Frank, Dr. Trey Rogers, and Dr. Thomas Green are all involved, as well as myself, in this research proposal. There are some striking differences that can be seen in these putting greens in the soils and how they've matured with time, in that basically what we see and what you'll see on this video is that with variable depth, and particularly in the lowest landscape positions, the lowest part of the putting green, they have aged much better with not near as much organic matter accumulation or movement and accumulation of iron compounds when it's variable depth as compared to when it's consistent depth. What we'll show you is 2 different constructions, variable depth and consistent depth with 100% sand, and show you the differences that occur in the accumulation of organic matter within that soil profile.
So this research green, what we're trying to prove is the long-term effects of time on a putting green, and how time and the elements, water, wind, precipitation affect the soil of a putting green. So this green was built in 1998. The data results were published in about 2005. However, it wasn't until about 2013 where golf courses started to implement this variable depth putting green in their construction methods. And I think so far they've seen good results with this variable depth putting green compared to our uniform depth, the old way of doing it. So now we're seeing many more golf courses implement this type of construction because they've seen the results, just word of mouth from other superintendents. They've seen good results, less labor, less water inputs, and overall better quality of putting green by just this new construction method. Right now, I think we have more golf courses going to start new construction this year, and we can see more in the future as well.
Okay, Dr. Crum and Dr. Green, and of course, Dr. Rogers, if you want to chime in on this topic, you can also. So I was curious when you were showing those soil profiles there, and that came from, I believe, the lowest point on that sloping green profile. So that would have been either a 12-inch depth or 16-inch depth, if I remember correctly. So my question was, you saw a big difference there in organic matter accumulation. Did you kind of see the same thing if you went up to that, like that peak of the slope?
Who would like to answer that? I will. I'll try to answer that, Kevin. To tell you the truth, we did not look extensively at the upper summit levels of the slope. What my expectation would be is that we would not see that same level of organic matter accumulation at the upper part of the slope as we would at the lower part. I think it's all about water and water management. I mean, organic matter accumulation is a natural process. It's part of soil formation. It's part of a putting green maturing. And golf course superintendents are always trying to decrease that rate of organic matter accumulation because of the control that it has on decreasing the sizes of the pores and the drainage that occur. And we're always cultivating or doing something or top dressing to dilute that soil organic matter. It's a natural process. It increases, the rate of accumulation increases as you decrease the amount of oxygen within the soil. That oxygen is decreased when water contents go up or are at higher levels. And therefore, what we see at those lowest landscape positions is greater amounts of soil organic matter when we have a consistent depth, we believe, because water contents are higher, oxygen contents are lower. Where we have thicker depths because of the variable depth construction technique, we see less organic matter, we think, because more oxygen, lower rates of organic matter accumulation.
Almost forgot to unmute myself.
I wasn't muted, was I?
No, you were not. You're perfect. I was getting ready to talk. I was like, wait, I might want to unmute myself. So that makes a lot of sense to me, Jim, because when I was thinking back to that original research, I remember we saw statistical differences in soil moisture contents at those lower regions. So like that 12 versus
correct.
16 is. But
That's
I remember
correct.
the 8 to 12 on the top of the peaks, although there was numerical differences, sometimes we couldn't ever get stats to separate it out.
Right.
So that makes a lot of sense. We did have a question that came in asking, is the gravel layer being adjusted depth-wise to achieve the contours on top that the architect is looking for in the variable depth method?
Dr. Rogers, you might be better suited to answer that question.
I might be, but I was sitting there hoping you would, because I was trying to figure out exactly what the question was, because the gravel depth stays relatively the same. One thing I'll say about implementing this work is if I've been involved in 10 of them, lack of another number to say, there's probably been 10 different methods by which it's been done. There is nothing really guaranteed with the exception of the depths. Sometimes somebody says, well, we want more gravel, less gravel, different size gravel. So somebody says, well, we're going to use 16 and 8 as our depths. How about 14 and 10? How about 14 and 9? So we've seen there's been a lot of differences there. So there's nothing really truly consistent that exactly plays off of this research. I was going to comment real quick on the upper regions where we only have the less depth, 8 inches, 9 inches, 10 inches. And I don't disagree, Kevin, that you don't see a separation out from the research. I think the only comment that I've received from people regarding those is that they don't seem to hand water those upper areas as much. Now, what kind of percentage differences does it take to prevent that hand water, and would that even show up in statistics, from a TDR standpoint? So our research versus what actually is practical in the field sometimes can be a little bit different, and this might be a case.
In the original research, the variable depth construction technique had much more uniform water contents across the entire surface as compared to the consistent depth. So, and that's why the superintendents don't have to water those upper regions near as much. We saw that, and it's an actuality.
We had one more question that has come in. Saying study was performed on 10% slope with 8-inch depth variability from high to lower regions of the putting green. On 5% slopes, would you recommend a 4-inch change from high to low?
4-inch. Oh, you mean change in?
Yeah, I think what the question is asking.
Thickness.
Yes, we went from 8-inch at the peak of the slope to 16-inch
15.
down the lower ridge. Would you, if it's a more gradual slope, would you go 4 inches difference? So
We did not do that in the original research. As I remember, it was consistent on both sides, 8 inches at the summit and then 16 inches below. Like Dr. Rogers was saying, we don't know that it's exactly 16 is the best answer. It could be 15, could be 14. So, I mean, 4 inches can work. Why did we pick 8 and 16? We picked 8, as I remember, because that's about the thickness of a cup. We didn't want to have to get into the gravel layer. And then why 16? Well, that's double it. That's the other 4 inches. So the net would be no net change technically or realistically in the amount of root zone that would be required within a putting green. That was our thinking.
As we wrap this segment up, any other questions either Dr. Crum, Dr. Rogers, Dr. Green would like to make before we move on?
I'd just say real quickly, we're very hopeful that we can get a funding from the USGA in this area, only because it will allow us to really document what do these greens look like 20 years later, which I think will provide a lot of information, positive information for those superintendents as they're trying to answer that question to their committees. You know, is this better? What can I expect? So this is something that doesn't come along every day. So hopefully we can get that funded.
Yeah, I agree. And one of the things that I saw in the consistent depth at the bottom of the slope is I saw a very slight accumulation of iron compounds, which some people are seeing across the Midwest and across the country. And you began to see that at the lowest part of the slope on the consistent depth construction technique, which is again indicating that we've got greater water content, we've got lower oxygen contents, and we begin to move and translocate some iron compounds. We didn't see it with the variable depth.
Excellent. Thank you, everyone. I think it is time to move on. So thanks for your input. Thanks for the video. It's a very interesting topic, and we look forward to kind of following this research as it progresses, hopefully over the next several years. So
thanks, everybody, for attending.
Yes, thank you, Dr. Crum. Nice to see your smiling face again. It's been a while.
Yes.
Okay, so next we have Dr. Tom Nicolai, who is going to give us a video presentation, and then we'll follow up with probably some questions and maybe even some additional slides. So please roll the video of Dr. Nicolai.
Welcome to the Hancock Turfgrass Research Center Virtual Field Day. Well, at least virtual for you. I'm here. The Hancock Turfgrass Research Center is one of the premier turfgrass research centers in the entire world. It was all started by this guy, Robert Hancock. He wanted to dedicate his money and life to promoting turfgrass research for the betterment of mankind. And some of the greatest experiments ever in the history of turfgrass science have come from here. But let's face it, here's what you're thinking. What have you done for me lately? Well, that's what Field Day is all about. So maybe we should take a look. Besides Robert Hancock, this place still wouldn't be here without dedicated individuals such as Mr. Gordon LaFontaine, who is the executive director of the Michigan Turfgrass Foundation for years. We've had lots of support over the years from industry, and I'd just like to start off by thanking all the board members over the years that have kept this facility running and is literally the envy of the turfgrass research world, basically because of your efforts. I really like these experiments that you can walk out and you just look at them and go, boom, something's happening here. This is one of those kind of studies. What I've got is a turf type tall fescue here. Looks kind of beautiful, nice, lush. You can see it's cut down in the alleyways here. And this is really kind of born out of like the idea of best management practices in biomass production. What we've been doing here for, well, this is now the second year of this study, is we've been taking and figuring out through TDRs the different amounts of moisture that is being in the soil based upon grass grown at 3 inches, 2.5 inches, or 2 inches. And we're weighing biomass. From other studies we've done on putting greens, we know that the lower the mowing height, the more clippings above ground that are produced. The thought process was, well, maybe there's a point of diminishing returns where that doesn't happen anymore. Here on these plots, and these are irrigated, they look absolutely beautiful, but we're getting the same thing. The lowest mowing height, all the way from down to 2 inches up to 3 inches, on like every occasion, is giving us more biomass. So maybe part of the take home is, if we can mow a little higher, we're producing less clippings and then leaving less on our lawns or roughs, or think about any other case like that. Everyone's always trying to make a better wetting agent. I mean, why not? If you know how to use a TDR and you have a good wetting agent, you can actually save money at the pump house. This is an experimental wetting agent project. We're on a USGA spec green, and I think you can probably see there's a difference of the amount of localized dry spot here versus back here. The big question with wetting agent experiments always are, if you're on flat ground, are we really getting good data? So I think what we've got to do is run the data, look at it, and see if this experimental wetting agent is really worth its weight of how it looks like it might be working when we're checking out what's going on in the soil.
Okay, looks like you're already going to screen share, Tom, so excellent. I will let you take this and I'll chime in with my questions or any other questions that come in. You are on mute, Tom.
As I just said, muted. It's amazing how better things go the second time around. Excellent. Thanks for having me. I hope everyone's recording this because it's such a beautiful day out. We should all be golfing. Except I can't get on because everyone's golfing. In any event, wetting agent research. Over the years, there's been some great wetting agents out there, and this is working with an experimental at different rates, and I thought I'd throw this in. Whenever we do wetting agent research, one of the things we look at is dew formation and how many days after application where we get less dew. That shows us that something's happening, but that doesn't always come back to showing us what's really most important. No one's going to really buy a wetting agent just because there's less dew if we don't end up with less localized dry spot. So in this study, and you can see from the video, certainly we had plots that fit right inside some of these squares that had a lot less localized dry spot than other areas. I'd love to share that data with you right now, but I can't because I have not run that data as of yet. We look forward to getting that out to you and sending it and seeing how this research working out. The other thing I kind of covered, which was really more of a lawn care height of cut study, but I thought was, to me, really interesting research about mowing heights and clippings. And that study that I talked about and we showed the video of on with the turf type tall fescue at the lawn height really came out of this study in 2013 that was repeated in 2014, where we were mowing putting greens at these three different heights, 0.080, 0.110, and 0.140. And as we did this data over a 2-year period, the one thing that was kind of struck me at first was just how much less or how much more the grass was growing at the lowest mowing height, which have led some people to then ask me, so that means that the lower I mow, the better chance of my green speed getting slower throughout the day because I'm actually producing more biomass. And what's funny, in this particular study, I wasn't even weighing that. It's like I got to go back and kind of do this kind of thing. In any event, because of this study, and you can see every time this lowest mowing height is giving us the most biomass production, we decided to take that out to the lawn care side of things for either the homeowner, the lawn care operator, or like I said, potentially the roughs. With this thought in mind too, when we were doing those studies at on the greens, this was the plots. These were the plots, and you could see each individual plot had its own mower. So 3 of these mowers happened to be set at 0.080, 3 of them happened to be set at 0.110, and 3 of them at 0.140. The reason that's sort of pertinent when I look back at this data is this is 3 different mowers all going into these different ratings, and we all know that it takes a very good mechanic to try and tweak all these things perfectly. So when we go in and we look at the lawn care study that we did the video on, these were our 3 mowing heights. This is data from last year, 2019. This is from irrigated plots, not non-irrigated plots. And when you go across here and you look at the 2-inch mowing height as compared to the 3-inch mowing height, always more clippings, sometimes extremely significant, 167 grams to 12 grams. That's an amazing amount of difference over a 1-week period. And because all these plots were mowed every 7 days. This last year, we decided that we should add into this study non-irrigated plots. So this is from this season, 2020, and plots that we didn't irrigate. And when we go through the season, not irrigating, mowing, again, every 7 days, we see the lowest mowing height coming up with lots and lots more clippings. Pertinent from a best management standpoint in some degree that if we can mow a little bit higher, we know that we can help keep some more weeds out and it stays greener a tad longer because the roots are deeper and it can harvest more water. And we then took and added up, this is our plots from overhead. So if you're a bird or you rented a drone, these are our plots. And if we look at this, this is our 2-inch height of cut as compared to our 2.5-inch height of cut as compared to our 3-inch height of cut. There you obviously see the difference in the greening. And these are replicated 3 times. If I add all the weights up from this study this past year, this is the non-irrigated plots. Notice they still kind of look green because they're all tall fescue, which does a pretty nice drought tolerance. In any event, the average amount of clippings from the 2-inch to the 2.5-inch, if I go to, the difference is the 2-inch produced basically 2 times as many clippings as the 2.5-inch. And if I go from the 2-inch to the 3-inch for this particular study, what we ended up with is we produced almost 3 times as much clippings. And on some individual dates, it was up to 4 to 5 times as much clippings, all depend on the variables. I was attending a meeting this summer where Dr. Bill Kreuzer of University of Nebraska was going back and doing what I was doing back in 2013, 2014, and he was doing with PGRs as well on his putting surfaces, and noticed the same thing, the incredible amount of clippings you can get at the lower mowing height. I'm going to go back in time here a little bit to set up another study we're doing at the Turf Center right now. This comes back to, I could call this the Christian Koval or the Adam Ickamus study. Back in 2002, we were doing studies at the Turf Center and comparing green speed with triplex mowers versus walk behind mowers. Besides us doing it, we asked other people to do it for us. There's Tom Beatty at Bend Golf and Country Club, and he was doing the same thing at his course as we were doing at the Turf Center, trying to get as much data from as many places as possible. When we did that data back in 2002, at Tom's golf course on his Poa annua at this cutting height with his mowers, there was basically a 6-inch difference in green speed between the triplex and the walk behind. The walk behind always giving us a faster green speed. We also did this down in Tennessee, Cherokee Country Club, again, 2002, because we're trying to gather as much data on this particular topic. When we did this from Cherokee Country Club down in Tennessee, the average difference in green speed over that time with the two different mowers, the walk behind and the triplex ended up averaging 1 foot slower green speed over that time. Another thing about a triplex, besides that slow down in green speed, or if you will, customer satisfaction, is that nagging triplex ring problem. And we've been working on the triplex ring problem, and we've done some research back with Jacobson a while back when they came out with their Eclipse mower with the frequency of clip, and we played with that and changed the frequency of clip and could help negate that triplex problem even more of that ring, and because sometimes it could be really bad. So the past 4 years, not last year in 2019, but 2018, 2017, 2016, we did what we called serpentine triplex mower studies with Toro. And we were doing these to help Toro get rid of the triplex ring. And that technology now exists on the new mower they have out, which is what the E-Plex mower. And the reason this all becomes pertinent is two things. One, when I was doing the research with Toro, I wasn't allowed to tell you that I was doing the research because we were tweaking it, using it with prototypes, and I had to sign off on an agreement. Now we know, mowers always give us different green speeds, great. Now, what I'm calling the Christian Koval Adam Ickamus study for fall of 2020, we've just started this week actually, but we're using the Toro E-Plex, the Toro Walk Behind, and the John Deere, and we're mowing straight lines and trying to basically see if, and I do believe, that we've gotten to such great technology today with these triplex mowers that they can really give us the same speeds as a walk behind. And we know from the research we've been doing that they can really help negate the triplex ring problems, which really kind of lead us to, if we can really get the customer satisfaction with this type of a mower now, with the labor issues that are involved and with the cost, can we just get the same customer satisfaction as far as green speed and mowing at the lower heights? Now, right now, we're only down to, we're at 0.125 and we're going to keep tweaking it down. And unfortunately, winter's coming. But we'll continue this study as we go into next year. But the technology is Dr. Rogers likes to say a lot, technology, stay on top of it. That's not a quote, paraphrase. Man versus machine wins, that kind of thing. And the technology has just really improved with these triplexes. Another study we're looking at this summer, this is the I call it the I Can't Afford a Roller for My Fairway study. Last year, when we had live conferences in Orlando, I was walking around the trade show floor and came up on this mower. The thing that really struck me about this mower was that back roller is extremely, this machine is extremely heavy. It's a really nice mower. You can mow your fairways with it. More so though, it would be something you'd mow your roughs with. Gives a very nice cut. But what I was concerned about with doing this study was, if I can buy this type of a unit, mow my roughs, and I can also use it as a roller with the cutting units off to roll my fairways, can I get less localized dry spot or less dollar spot? We know from studies we've done with other rollers at Michigan State University that we can get less localized dry spot by rolling the fairways. We've seen that year after year. What I have not ever documented at Michigan State is less dollar spot by fairway rolling. And this seemed like a very good tool to try, because it could do, if I can mow my roughs with it and roll a fairway with it, it becomes a dual action machine. Now, if you weren't on earlier, you may have noticed that Joe Vargas was talking about, we haven't had a lot of dollar spot yet this year. So we haven't got a lot of counts yet, but hopefully we'll get some before the year's out. In all truth, a lot of the research we've done in golf this year, if I really try and weigh it down, it was a little lightweight, a little bit because of the COVID experience we had. But what other data are we looking at and have we gone over in 2019 that is running on? Well, first of all, I'd like to thank both Jared Milner and Aaron Hathaway. If you have your course conditions September issue, you'll see I wrote up, they helped me write up, the data from a fairway study we did in 2019, and we've tweaked that study, added some new stuff to it, and that'll be coming out, and we'll get that data to you certainly by December as we mail out stuff. We are working with ProCure now on greens and fairways. We've made some apps, not seen much yet. First app was just 3 weeks ago. We were hoping to start it in the spring, but because of COVID, we didn't get that spring treatment down because I really wasn't allowed to. And we're also working with some other experimental POA control research that's for putting greens. So I'm not allowed to tell you about this one for several years, but it's exciting, and we're bringing in funding. I want to close with reminding you that this publication, Turfgrass Weed Control for Professionals, really has a lot of has all the information that you could possibly want. It has lots of weeds in it. And for golf course managers, I think the most exciting stuff is, I'm gonna compliment a lot Bill Kreuzer on that, but there's 16 universities that put information into this document. Dr. Aaron Patton puts it all together really well. This is the link you can go to, or you can get on so that you can order yourself this magazine. I think it's a must-do. I ordered one and gave one to every one of my students last year, and if I get to see them live this year, I'll do it again this upcoming year. Great publication that I'm just happy that to sort of contribute to. If you have any questions about any of this information, if you'd like a slide, or if you'd like the data when my data comes out, there's my email. If you'd like to text or call me, there's my phone number. Thank you very much, everyone. Stop share. And
Thank you, Tom. We had a question come in while you were talking. Do you always suggest to water in soil wetting agents, even if it's tank mixed with fungicides?
I'm sorry, what?
The question was, do you always, or do you suggest to always water in soil wetting agents?
The wetting agents I'm doing the experiments with, the answer is yes.
Okay, follow up. How about if it's in a tank mix with fungicides?
That would probably depend upon the fungicide, so that might be a good Nancy Dykema, Joe Vargas question. I would imagine with some insecticides, that would probably work fine because a lot of insecticides I know get watered in. Nancy, what fungicides do we water in? Or Joe?
We water them in when we're trying to get them down into the problems on the roots, like summer patch or tickle.
Well, that sounds like a future experiment we should do next summer.
Yeah, it does. Okay. Interesting to see.
Thanks for the question.
Thank you, Tom. I don't think we have any more questions, so I think we're going to move on to our next presentation. Thank you once again, Tom. So our next presentation is Jackie Guevara, and we will roll that video right now.
Good day, everyone. My name is Jackie Guevara, and I'm a master's student in crop and soil science with a focus on turfgrass soil fertility. And my advisor is Dr. Kevin Frank. I will talk about our research regarding the effects of different soil testing interpretation philosophies on creeping bentgrass and annual bluegrass potting greens. Soil testing is an important part of turfgrass management, especially in developing our fertility programs. There are 4 major processes in soil testing. First, we collect the soil sample. And second, we send those soil samples to the laboratory for soil analysis. And this analysis will give out ambiguous numbers that we cannot directly use in the field. So, third, we need to interpret those results. And this is where the soil testing interpretation philosophies comes in. These interpretation philosophies are equations or formulas which we can plug in the numbers, the ambiguous numbers from the soil analysis, and then convert them to applicable nutrient recommendations. In this study, we observed 2 soil testing interpretation philosophies. The first one is the sufficiency level of available nutrients, or SLAN. It was based from agriculture and over the years was refined for turfgrass use. It is the most commonly used interpretation philosophy in the United States. It is currently used by the MSU Soil and Plant Nutrient Lab. The second one is the Minimum Level for Sustainable Nutrition, or MLSN. It is relatively new. It was developed by Dr. Micah Woods of Asian Turfgrass Center, Dr. Larry Stowell, and Dr. Wendy Gelernter of PACE-Turf. They based the MLSN guidelines from thousands of soil samples from well-performing turf grass. Let me briefly explain how each interpretation philosophy works. On the upper part of this slide is the soil test result, and the lower part is the SLAN guide from MSU Soil and Plant Nutrient Lab. Since the pH of the soil is 8.1, we will look at the Olsen P test value, which is 4 ppm. In this table, 4 ppm will yield 3.6 pounds of P2O5 per 1,000 square feet recommendation for a sand-based root zone establishment. On the other hand, MLSN has its equation and guideline. MLSN equation is nutrient recommendation is equal to A, which represents the nutrient used by the grass, which can be computed using 2 methods. The first one is based on nitrogen use. So for phosphorus, it's 1/8 nitrogen, while for potassium, it's 1/2 nitrogen. And the second method is using the temperature-based growth potential. So that's A. Plus B. B represents the amount of nutrient levels in the soil to maintain good turf quality, which can be found in the MLSN guideline. Minus C. C represents the amount of nutrient that it was already in the soil, which can be identified through Mehlich tree soil test analysis. This is the experimental design. There are 2 research greens, The first one is the Pen A4 Creeping Bentgrass or A4 Green, and the second one is the mix of Creeping Bentgrass and Annual Bluegrass or the Mixed Green. Each soil testing interpretation philosophy has 3 replicates, so there will be 9 plots per research green. We also added a traffic component in our study. Using this traffic simulator, which weighs approximately 100 pounds, I made 6 passes 3 times a week to simulate for 170 rounds of golf per week. We did this so we can analyze and observe how each soil testing interpretation philosophy will perform under stress and non-stress conditions. This is the experimental design with the traffic component. And to give you a better visualization of how this research really looks like, let us watch this video.
Good day everyone, my name is Jackie Guevara and I'm a master's student in Crop and Soil Science with a focus on turfgrass soil fertility under the supervision of Dr. Kevin Frank. Welcome to my research plot, and I'm working on the effects of soil test interpretation philosophies on creeping bentgrass. And in this study, there are 2 experimental green. On my right is an A4 bentgrass green. We call it the A4 green. And on my left is a mixed stand of Pencrest bentgrass and Annual Bluegrass, so we will call it a mixed green. Here we are on the A4 green, and we can see the 3 soil test interpretation philosophy treatments. Each soil test interpretation philosophy plot was split into traffic and no traffic plots. In this MLSN plot, even though there is a lower amount of fertilizer put into it, there is no difference between this one and with the SLAN plot. However, we can show a difference in this control plot. We can see or observe some signs of feed deficiency. There is a darker green color and a little bit of purpling as well. We are here on the mixed green, and the first one is the SLAN that has 1.5 pounds of N, 0.61 pounds of P, and 4.41 pounds of K, while in MLSN there is a 4.77 pounds of P and 1.38 pounds of K. We can see a big difference, almost 3 times difference between MLSN and SLAN in terms of the amount of K being put into the soil. For the urea only, or the control plot, we're going to only apply 1.5 pounds of N without any P and K in it. Here in the mixed green, we can see the same result as the A4 green. There is this darker and almost purplish color with the urea plot, which is a sign of P deficiency. And we cannot see that in both MLSN and SLAN plots.
The data we collected from the research are the Normalized Difference Vegetation Index or NDVI, Visual Rating of Turfgrass Color and Quality, and soil analysis. We sampled the soil on the first year on May 2019, while on the second year it's November 2019, and we sent those soil samples to the MSU Soil and Plant Nutrient Lab. First year results. Let's start with soil analysis. This is a soil test analysis for A4 green. A very important observation here is that SLAN has a statistically higher soil P and K values compared to MLSN and control treatments. And based from the initial soil test analysis, SLAN had an increase in both soil P and K levels. While MLSN, there is this a little bit of increase in ozone P, a decrease in malic P, same ammonium acetate K values, and a decrease in malic K. In the mixed screen, we can observe the same pattern. SLAN has a statistically higher salt P and K levels compared to MLSN and control treatments. SLAN had an increase in both salt P and K levels from the initial salt test analysis, while in MLSN, there is a little bit of increase in Olsen P, a little bit of decrease in maleic P, a decrease in ammonium acetate K, and a decrease in maleic K. This is the second-year nutrient recommendation based from November 2019 salt test results. This is the recommendation you observe in the video. Because there was a buildup in salt P and K levels in SLAN based from the November 2019 salt test results, you can notice here that the SLAN recommendation for phosphorus is already lower than MLSN. However, the SLAN recommendation for potassium is still 3 times higher compared to MLSN. Let's proceed to the Normalized Difference Vegetation Index, or NDVI. NDVI quantifies and measures the light reflected by the grass. So it's correlated with the turf grass color. For A4 green, you can observe that there is no statistical difference between the salt test interpretation philosophies, both in non-traffic and traffic plots. For the mixed green, there is no difference between the salt test interpretation philosophies, both in non-traffic and traffic plots. However, there is this lower NDVI values observed in traffic plots compared to non-traffic plots. For the visual rating of turf grass color, in A4 green, there is no statistical difference between the salt test interpretation philosophies on both non-traffic and traffic plots. However, the traffic plots has lower or like a lighter color compared to the non-traffic plots. For the mixed green, there is a difference between the salt test interpretation philosophy treatments. The urea-only treatment has a lighter color compared to the MLSN and SLAN treatments. And the same pattern was observed in traffic plots, but there are still a lighter color compared to the non-traffic plots. Lastly, the visual evaluation of turf grass quality. I evaluated turf grass quality based from uniformity and the presence of traffic marks. So given that, we expect that in both A4 and mixed green that the traffic treatments has lower turf grass quality compared to the non-traffic plots. And in terms of salt test interpretation philosophies, there is no statistical difference between all of them. A brief summary of our research. Following 1 year of fertilizer treatments, P deficiency symptoms were only observed on urea-only plots. And SLAN had an increase in salt P and K levels, whereas MLSN retained initial salt P levels and had a decrease in salt K levels. There were no significant difference or statistical difference between the salt test interpretation philosophy treatments for turf grass quality, color, and NDVI. And we also observed that traffic plots had a lower turf grass quality, color, and NDVI compared to non-traffic plots.
Okay, thank you, Jackie. I guess just a couple things I noticed from your study at this point, Jackie, is I guess one big take home is really your conclusions there that between the two methods that we're using, the MLSN and the SLAN, that you're really not seeing any differences among those treatments, correct?
Like, yeah, visually there are no difference between the two.
salt test interpretation philosophies.
And I think that's kind of a big conclusion right there, just because when you look at the amount of nutrients you're supplying for the S-land, which with higher rates being returned of phosphorus and potassium compared to MLSN, and you're not seeing any visual performance differences, whether it's trafficked or not trafficked.
Yeah.
That certainly is significant from my standpoint, just when you look at the amount of nutrients you're putting down. And the second thing I think that just didn't show up in the pictures very well, or the video, is just, you were seeing, I think, a little bit of discoloring that was possibly from phosphorus deficiency on that low, or just the N only, right? The N only urea.
N only, yeah.
Yeah. Okay. Anything else you want to add, Jackie, as we wrap up?
I think we're good.
Okay. Do you think you're going to continue this study? As I know your plans possibly to go on for a PhD. Do you think you want to continue this work further, get some more years of data?
Yeah, I probably I'm looking forward to seeing like the long-term effect of both salt test interpretation philosophies on the potting green. Yes, okay. Dr. Nikolai.
Yes, Jackie, very good work. I enjoyed it. When you're trafficking and you're pushing that machine that weighs 100 pounds or whatever, and you go back and forth 6 times.
Yeah.
I think it's important when you write your dissertation, is the heel of your foot putting down more PSI yours, or is it the traffic simulator? Answer that. Take care.
If I'm adding more pressure to the soil, probably not. I think I'm even lighter than that simulator.
You're allowed to tell me to shut up, Jackie. Good job. Good.
Jackie, you don't know Tom as well as some of us, but that would just be a Nikolai, is what some of us refer to that as. And that's kind of how we'll conclude today. So that kind of wraps it up. We now have the credit information, which will look at both the MDARD pesticide recertification credit information and then the GCSAA education points. So the link to get the survey, which is what is on your screen now, that'll be pasted into the chat box momentarily. And then you can go to the chat box and follow that link to fill out the survey. We did have one question that I thought came in, Jackie. What was your soil sampling depth? You might have covered it, but I know I've probably forgotten already.
It's 6 inches.
6 inches, okay.
Yeah.
Another question was cation balance theory. Could we add that in? We could probably add that in. It'd be a little late doing it 2 years now, but that would be certainly another soil testing philosophy theory that we just didn't include in this initial trial. But like we said, Jackie seems to be interested in a PhD, so maybe she'll add that one for some more work to do. So looks like now we have the information in the chat box for the survey to get the MDARD credits, and then for those of you looking for the GCSAA education points, 0.10 education points gives you the code there in the chat box, and then of course you either call GCSAA and give that information, or I think there is a form you can submit through the website also. We will stay on the line here for just a couple moments. I know we're already a little bit past noon, and if you're like me and you're in the Eastern time zone, you're beyond ready for lunch at this point, but we'll hang out, see if there's any questions. If I don't see any more questions, we'll start to shut down. We'll leave it up here for a little bit just so you can get that credit information out of the chat box. And I just want to conclude it as we wrap up by thanking all those sponsors of the Hancock Turfgrass Research Center that help us with supplies, whether it's fertilizer, pesticides, certainly our equipment donors. Also want to thank Jesse Scholl, who is a farm manager here, and Adam Palmatier, who is our irrigation technician. Adam just left for a new position, but we certainly appreciate his efforts over the year to keep this place running, which is certainly, Jesse and Adam, it's been a challenging year, as you can imagine, like many of you had, with different restrictions on what could be done and how many employees we had and all that sort of thing. But we got through it. We're getting through it. And it's been, I think, a successful year, although a challenging one. Finally, definitely want to thank the Michigan Turfgrass Foundation for all their funding, even throughout this year, and helping us keep going with some of our research efforts. And thanks to the Michigan Golf Course Superintendents Association for their support. And once again, I will on behalf of the turf team, thank the golf course superintendent, since it's Thank the Golf Course Superintendent Day. Looks like we're, so that's probably end of my comments. Thanks everybody for attending. Appreciate your support and hope you have a great rest of 2020. Certainly been a challenging year. If you're like me, you're ready for 2020 to probably be over. So thanks again.